Assalamu alaikum students. Today our lecture is on logic gates. This is basically chapter 10 of new book of computer science. Last time this was the third chapter of computer science. Right now they have shifted from paper 1 to paper 1 to paper 2. So now you have to work out according to that. So basically now we start what is logic gates. Basically, what is meant by logic gate? Logic gate is an elementary digital circuit that processes binary input based on Boolean algebra, producing binary output accordingly. So this is the definition of logic gate. So we can understand how to do that. Logic gate, basically the purpose of logic gate is to produce like truth table, logic statement, and it gives basically it gives understanding of how internally a computer electronic circuit are working. Okay, so move on next slide. These are 6 basic logic gates are given in your book. So 6 different logic gates will be considered in this chapter. Okay. First one is NOT gate, second is AND gate, third is OR gate, fourth is NAND gate, fifth is NOR gate, and sixth is OR gate. Remember, only one input is given for NOT gate. Means if you input 0, it will be 1, and if you input 1, it will give output of 0. Other gates will have 2 inputs. So we'll see how these all gates work together. So we will see one by one its function and requirement. Whenever you are given questions on logic gate, you have most of the time you have to produce truth table. So truth table are used to trace the output from a logic gate or logic. So you have in question you might be given a diagram, and you have been asked to produce a truth table. So the NOT gate is the only logic gate with one input. So the other 5 gates have 2 inputs. So remember that if one input is given, so 2 power 1 equal to. So whenever we basically draw the truth table, we have to see how many inputs are given. Like one input is given, so 2 power 1 equal to 2. So two combination you have to produce in your truth table. If 2 inputs are given, so 2 power 2 equal to 4. So 4 combination you have to produce in the truth table. And if 3 inputs are given, 2 power 3 equal to 8. So 8 combination you have to produce in truth table. And if you are given 2 power 4, it will be 16 combination of inputs. So to produce the output. So we'll see one by one each one as requirement. So you have to draw input table, input columns first, then you have to draw intermediate column, working column, and then you have to produce output, final column. Okay. So these are some truth tables are given. This one is it is a combination of basically 2 power 2 equal to 4. So 2 inputs are given. So it must have another output column. Here you can see C, you can write C or output. So whatever output will come according to logic gate given, like NOT gate, AND gate, OR gate. So we'll have to produce output according to that. Now you can see 3 inputs column. So there are 8 combinations are given. This is this 3 input, and this is 4 input column. So you must have seen that there are 16 combinations are given. Remember that whenever you have to produce truth table, first see how many inputs are given. You have identified these 2 inputs are given, 2 power 2 is 4. So how to put 0 and 1 on each one? First write A. If it is 4 combination, in first column, first write 2 0 2 1, and second column 0 1 0. This is the sequence to draw inputs column, to write input column. And if you see 2 power 3, this is 8 combination. Now here you can see in first column write 4 ones and 4 zeros, 4 ones, and then 2 0 2 1 2 0 2 1, then 0 1 0 1 0 1 0 1. So according to this sequence, you have to draw your input columns. And if you see 2 power 4, there are 16 combinations. So in first there will be 4 inputs. So in first column, that would be A, write 8 zeros and then 8 ones, 8 zeros and then 8 ones. And second column, 4 zeros, 4 ones, 4 zeros, 4 ones. And third column, 2 0 2 1 2 0 2 ones, so 2 ones and 2 0, 2 1s, 2 zeros, and 2 1. This is the sequence how to write input column. Then 0 1, 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 then 0 1. Okay. Now, third requirement which can which we need to always practice, like you have to write logic statement. Most of the time, logic diagram is given, and after seeing the logic diagram and understanding, always practice to write a logic statement. So it will help you to produce truth table very easy. Even you are given truth tables and you have to write logic statement, then you can draw the diagram. So a logic statement refers to a representation of the logical relationship between input and output using logic. So it will make your it gives easiness to draw the logic circuit easily or to produce a truth table easily. It defines how the output of circuit is determined based on the input values and the logic gate used, such as AND or NOT gate. Logic statement express the behavior of the circuit in terms of Boolean logic. So we'll see how to draw logic. I will tell you the key point how to draw logic statement. Normally, in logic gate, there are 4 types of questions are you have to solve. Like in logic gate, most of the questions are asked from student as follows. Logic diagram is given and to produce table. So most of the question comes like this one. Next requirement could be like that logic diagram is given and to write the logic. But in each question, you have to practice to write a logic statement. Third requirement can be logic statement is given and to draw the logic circuit diagram. Okay, logic statement not normal, and you have to draw logic circuit diagram, and after that you have to produce truth table. It depends on question. Fourth requirement, which is very rare, but it can come. Truth table is given and to write the logic statement and or to draw logic circuit diagram. So these 4 kind of questions can come in your syllabus. Now let's see next. Okay, this is the NOT gate. Here 3 columns are given: description, truth table, and how to write this. So these all you have to understand. You can read like this. This output X is 1 if the input A is 0. Means if you are inputting 0, it will give 1, and if you are inputting 1, it will produce 0. So basically, invert the inputs. Truth table, you can draw the truth table. A would be input 0 and 1, and X would be output 1. If you input 0, you can have output of 1. If you input 1, you can have output of 0. In how to write this? Now you need to understand X equal to not A. X equal to not A. So whenever you are given not gate, you can write like logic notation. Boolean algebra most of the time is not come. So you can write here X equal to A bar. So this is the notation how to write in Boolean algebra. But normally this type of expression does not come in Boolean algebra. Okay. Second is AND gate. AND gate basically is worked on multiply. So here you will find 2 input A and B. The output X is 1 if both input A and B are 1. So if both input have 1, then you can have an output of 1. So you can see from truth table, if 0 basically works on multiply product. It's a product, basically work on product. So if you multiply 0 multiply 0, you will have output of 0. 0 multiply 1, 0 multiply by 0, output of 0. 0 multiply 1, you will have output of 0. 1 multiply by 0, you will have output of 0. 1 multiply 1, you will have output of 1, as it is written in the description. You can write how in logic statement X equal to A and B. So this is logic statement. In Boolean level, you can write X equal to A dot B. So always remember dot means multiply. Dot means multiply. So you have to work on that. Third gate is OR gate. OR gate works on addition. OR gate works on addition. So here it is written the output X is 1 if either input A or B or both are 1. Okay. So you can see from truth table 0 plus 0 plus 0 equal to 0. Remember 0 plus 1 it will give output of 1. 1 plus 0 it will give output of 1. 1 plus 1 it will give output of 1. Okay. So remember this logic. You can write logic statement X equal to A or B. A or B. You can write this one. In Boolean algebra, you can write A plus B. So we use plus sign for OR gate. Okay. The third one. Now NAND gate, or you can read it not AND. Here it is given This is the reverse of basically AND gate. So always remember, whenever you are given NAND gate, you have to draw true columns to perform to produce the right output. Basically, here is given like 0 and 0 is 1. It should be proved that first we will draw a column of A and B, and then you can reverse A dot B this one. So 0 multiplied by 0 output will be 0. 0 multiplied by 1 output 1. Okay, this one, and 1 multiplied by the 0 output is 0. 1 multiplied by 0 output 0. 1 multiplied 1 output 1. Now you can revert this one. This would be 1. This will be the second. 1 second. 8 seconds. So I need to remove this one. I'm writing it again. Okay, draw two columns. First one A dot B, and then A dot B bar. Okay, always give another name of letter. Like you can write A dot B P, or you can write here P bar. Okay, so 0 multiplied by 0 output would be 0. 0 multiplied by 1 output would be 0. 1 multiplied by 0 output 0. 1 multiplied by 1 output 1. Now you can revert this one. This would be 1, this would be 1, this would be 1, and this would be 1. Okay, so you can see this output is the final output according to that. Okay, you can write this one x equal to A and B. So this is logic statement, and in Boolean you can write x equal to A dot B bar. So first AND operation is performed, then you can revert AND output to so you can revert the AND output. So it will be original ones. Okay, this is NOR gate. You can read it not OR. So you can read it not OR. Here also you need to draw two columns again. So you remember OR gate works on plus. So this is A plus B, and this is A plus B bar. You can write there. 0, 0 plus 0, it is 0. 0 plus 1, it is 1. 1 plus 0, it is 1. 1 plus 1, it is 1. So now you can invert this output of A plus B. So it will be 1, it will be 0, 0, it will be. So remember, NOR gate output is always reverse of OR gate. So you can remember like that. Here is given the output X is 1 if neither input A nor B is 1. And you can write logic statement A nor B. Okay. Or in Boolean level, you can write A plus B bar, A plus B bar. We will read according to that. Now you can see this is very special gate, the OR gate. Okay, this is little typical. It's simple logic is that you don't need to draw two columns of this. You can just remember the logic. If similar bits are given, output always 0, like this one. Okay, output always 0. If dissimilar bits are given, output will be 1. Like 0, 1 is 1, 1, 0 equal to 1. So its reading is basically complex gate. The output X is 1 if input A is 1 and input B is 0. So both input must be different. So you can produce output 1. Or if input A is 0 and input B is 1, so you can produce 1. You can see how to write this. A is OR B. You always write A is OR B, logic condition. Even you can write this one, Boolean algebra. A dot B bar plus A bar dot B. So it is Boolean algebra. Note this is written as A plus B or dot, this one, multiply, and A dot B bar. So you can write these three different ways, but normally we follow this one. So these are some basically functions of logic gates. Now we see next one. This kind of question you might have been given. So working columns or working state must be given in logic gates question. Now, when you see such kind of question, try to write logic statement first. So I'm here writing, you can write logic statement like this one, X equal to 1. It will help you to draw truth table very easy. So you can write, now first see, A is connecting with A and C are connecting with OR gate. So you can write x equal to 1 if first right bracket and another right bracket, open bracket. A, this one A, it is connected through C with the OR gate. So you can write A plus B. First one is solved. Now you can see this A, output of A plus B will be input of XOR gate, next gate. Okay. So here you can see A plus B. So it will be input of XOR gate. So it means here you can write XOR and XOR also connected with B. So B, A plus B XOR B. So this is complete logic notation of these two gates. Okay. So you can close this bracket. Now see, this gate is connecting with NOR gate. It means, and from this is also connecting with NOR gate. So central gate will be NOR gate, right? NOR gate, and then finish this one. B is connecting with C using NOT gate. So you can write B equal to NOT 1. And the next gate is AND. So it is connected with C and C. Bracket close and final bracket. Always write logic statement like this one from gates. So it will help you how to solve. What will be the sequence to solve the column. Now draw. You can draw. First one is A plus B. Now draw this diagram, this column. So it will be A plus B. You can give the name of another letter name like P. I always use this. So A plus B, sorry, A plus C. A plus C, right here. Okay, wait. Basically, it's A plus C. C and C. Okay, A plus C, plus means it shows OR gate. So you can plus two numbers of any. 0 plus 0 would be 0. 0 plus 1, it will be 1. Okay, 0 plus 0, 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, you can write 1. 1 plus 0, 1. 1 plus 1, 1. Okay. Now A plus C is finished. And next one would be B naught. Now try to write B naught. Even you can write basically P XOR B. Okay. Here another column we can produce P. Basically this P, this is connecting with this one. Okay. So you can write P XOR B. Okay. You can give another letter name like R. I am giving R. So P XOR B. Remember, XOR logic is whenever you see different bits, it will produce output 1. So this is the column of P, and you have to connect with the XOR B. Yeah, like you can see B is going here. Now B going here. Okay. So the P XOR B. You can write P XOR B. Okay. P this one and B this one. 0 plus 0, output would be 0. Okay. 0 plus 1, output will be 1. 1 plus 0, output will be 1 because both are different input. 1 plus 1, output would be 0. 0 plus 1, output will be 1. Okay. 0 plus 1, output will be 1. Now similar bits produce 0. 1 plus 1, 1 XOR 1, output will be 1. 1 XOR 1, output would be, sorry, here 0 and here. Remember, basically similar bits produce 0 and dissimilar bits produce 1 in XOR gate. Remember this logic. Now this gate is finished. This gate is finished. Now you need to see B naught and C. So first produce B naught. So it will help to produce final column of B naught and C. B naught means you have to revert all bits of B in reverse order. Now this 0 will be 1. This 0 will be 1. This 1 will be 0. This 1 will be 0. This 0 will be 1. this 0 will be 1, this 1 will be 0, and this 1 will be 0. This is B naught. Double 1, double 0, double 1, double 0. Okay. Now this B naught is passing from AND gate, and C, there is another input of C. So you can write B naught dot C. And for AND gate, you can write dot. Or okay. You can give the name of B naught and C Q. I'm giving Q column. Okay. So this is B naught and this is C. 0 multiplied by 1. 0 multiplied by 1, it could be 0. 1 multiplied by 1, it will be 1. 0 multiplied by 0, it will be 0. 1 multiplied by 0, it will be 0. 0 multiplied by 1, it will be 0. 1 multiplied by 1, it will be 1. 0 multiplied by 0, it will be 0. 1 multiplied by 0, it will be 0. So here you can see 0, 1, 0, 1, triple 0, 1, 0, 0. So this is the output of basically B naught C. This gate and all these two gates have been solved by Q column. Okay. Now this column name is basically okay. Now I told you the final gate is NOR gate. Whenever you see NOR gate or NAND gate, you have to produce two columns. So I am producing this one. Okay. So you can produce R and R plus S. So I have given this is R column and this is R column and this is Q, sorry, Q. Okay. Now this is OR gate, so 0 plus 0, output 0. 1 plus 1, output 1. 1 plus 0, output 1. 0 plus 0, output 0. 1 plus 0, output 1. 1 plus 1, output 1. 0 plus 0, output 0. 0 plus 0, output 0. Okay. Now R plus Q, you can revert. X would be the final column. Here you can write here R plus Q, R plus Q bar. Okay. This will be 1. This will be 0. This will be 0. This will be 1. This will be 0. This will be 0, 1, and 1. So after that, you can see 1, 0, 0, 1, 0, 0, 1. This is the final output. You can confirm from the next slide. You can see 1, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 0, 1. So this is the final output. How look. So always use working space to produce additional column. So it will be beneficial for you to produce the right output of given diagram. Okay. Thank you so much. Have a nice hope. I hope you must have understood. I will make further videos on logic circuit, so different papers, so you can understand more easily. Thank you so much.